Hey, what's going on, guys? GUI here. I've added piece list to my mood generator, and now it finally works faster compared to JavaScript version of CHESS Engine by Richard Tolbert, also known as Bluefiva Software. So for this tricky position at the depth 5, we have this time for Wise, while Wukong seems to be kind of faster here. While at the same time, for some reason, if we run the perf test at the depth of 4, then Vice would be running for about 7 seconds, while Wukong for about 10-11 seconds. So it's quite pretty unclear to me personally, to be honest, why Wukong performs more poor in lower depths and why performs better at deeper depths. It's a little bit of a mystery for me at the moment, but anyway, the fact is that this depth 5 actually searches faster, which is generally kind of really kind of nice stuff. And so what the piece lists are and how they work basically, so some sort of a critical part within the mode generator that actually improves the performance. So before I had piece list, the way of getting the source square, the matter of getting the source square occupied by a certain piece was the matter of making a loop over all the board squares, picking up only those board squares which are on board, assuming the hexadecimal 88 board representation is just a matter of the single bitwise operation, like square bitwise ended with a constant of hexadecimal 88, and if the result is equal to 0, that means that the square is on board actually. So but that's a little bit of time and effort, time consuming basically. So there is some sort of an improvement. We can keep track of the data structure that counts the material, so we know how many pawns, knights, bishops, rooks, queens, and kings for both colors we have. So here they are stored. This piece list gets initialized once the FEN gets parsed, and then we are associating for every single piece. We associate a square where this piece actually stands. So if I have a look at the initialize piece list method, that's exactly the stuff that is happening. So first we just reset the material. Okay, so from the white pawn and up to the black king. Okay, and actually then we reset the piece list itself. And well, this multiplication is because JavaScript doesn't have the two-dimensional array in the way how C programming language does have them. So a bit of a calculation is needed to mimic this two-dimensional array stuff. Well, probably it's not the most efficient, especially when it comes to updating the piece list, assuming that JavaScript has double type for numbers, which makes the multiplication quite pretty expensive. But anyway, still at the moment that's how it works. So maybe one day I would improve this to make it faster. So anyway, here we associate the pieces with the squares where the piece actually stands, and also obviously at the same time we're counting the material. Now the idea is, if we just go back to our generate moves function, generate moves. Now instead of, as I was mentioning already, so instead of making a loop over the board squares, instead, hold on a sec, it's not that. Yeah, here, generate moves. So instead of making the loop over the board squares, we make a loop over all the piece types, starting from white pawn and up to the black king. And then we'll loop over piece index, which literally means the piece count. So like we have white pawn, then we need to loop over all the white pawns available. We have like white knight, then we need to loop over all the white knights available, and so on. And now to define the source square, we're making it in a very simple way. So simply just referencing the pieces and calculating the index based on piece and the particular index. So say the square for first pawn, for second, third, and whatever, no matter how many pawns we have there. So up to, so a maximal number is 10 for every piece. That's the reason for multiplying by 10 here to obtain this to obtain this kind of like index within the pieces. And then all this stuff is literally the same. So I've been showing you this refactored code of the mood generator. So now it's quite pretty tight, nice, good looking, and working quite pretty fast. So the very last thing, in order to make it actually work, we need to update the piece list within the make move function. So I've made a little bit more refactoring. So all the manipulations with the piece list are happening within these three functions. So move current piece, remove piece, and add piece. Well, I should have called this move piece instead of move current piece, but I already have the move piece function that is used by the GUI. So probably not the best ever name, but or maybe I should call this one move piece and that one in the GUI, like move piece in GUI or something. So naming these functions. So I might be changing these names later on. But anyway, so we have exactly three cases. So if we just moving the piece on the chessboard, this means that we need just to pick, we're just looking for current piece. So and if we just finding the piece, so we have a source square. Okay, so if we're finding where if we do manage to find a piece on the source square, in this case we just assign the value of the target square to the same piece. So it's quite pretty easy. Now it's a little bit more complicated with removing piece and added pieces. Well, adding piece actually works exactly the same as we do adding the pieces within the init list. So we just actually taking the current piece type, this one, and associating it with the square, and then we just incrementing the count for current piece, because previously the count was incremented, so now the pointer of the very last piece of a particular type actually points to a new element. So we can just create we can store this new square straight ahead, and then we just need to update this piece counter. When we're removing piece, it's absolutely the same, but on the contrary. So first we need to decrement the piece, and then we just this line is a bit interesting. So we're putting the very last element. Let's say we have like 10 pawns. Okay, so we decrement this pawn counter. So now the last pawn so this becomes the last pawn. Okay, the square for the last pawn, and we just making it equal to we're assigning the value that the last pawn was equal to the pawn that was kind of captured or removed or whatever. So this is a little bit tricky to understand, but if you have a look at the source code, just try to read through this, you will definitely understand like what's going on under the hood. And obviously this piece of code is needed to actually pick up the proper piece we're working with. So we actually need to obtain the index of the piece that is about to be captured or literally removed. So that's how it works. The simple replacement schema here. And then within the move list, within the make move, we either move in piece, or we also can remove piece. So it happens like on captures, on in peasant captures as well. So where am I in peasant captures? So here on in peasant captures, the same stuff. We're moving pieces on castling when we need to move the rook. So literally we incrementally updating not only the board state but also the piece list back. Forth and back and forth. So the same stuff happens when it comes to the takeback function. So again, like we need to either add piece or move piece or whatever is needed there. So we need to make sure that the state of our piece list always matches the state of our chessboard. Only in that case we can make sure that we would actually be generating correct moves. So that's quite a pretty important thing to consider. And this took me quite a bit of time and effort to implement it. This is the very first time I was doing this consciously, to be honest, and this was very fun and exciting work to do, to be honest. I don't know, I really enjoyed this debugging, because I don't know, it's just very, very exciting to me personally. So now I'm really proud of this particular move generator I have, despite the fact it's still kind of very slow compared to how it could have been, but at very least, assuming the algorithms that been involved here, it kind of works it kind of almost does the best it can. So the most significant part that actually slows down the process is the is_square attack function. So have a look at this. And the problem with this is_square attack function is that it's the most heavy function in terms of processing time. It takes for about, I don't know, from 60 to probably even 70% of the entire execution. I was profiling my code. That's the reason why I know this. And every time we're calculating these attacks on the fly, and this is_square attack function is used in order to answer the simple question whether the king has been exposed into a check or not, when you're making a move or when you're validating castling. So to make sure that king is not jumping over their attacked square and not finds itself under the check when he goes to the target square. So that's kind of it. And the way people do usually, with the bitboards, it's not a problem anymore, because with bitboards we have the pre-calculated attack tables, and the matter of answering the question of whether the square is attacked or not is just a matter of a simple lookup. And if you're interested in how exactly that could be implemented, please feel free to check my bitboard chess engine in C series here on Chess Programming channel. A very, very extensive tutorial series explaining how that could be done. And another option that I read in Chess Programming Wikipedia recently is keeping track of so-called incremental updated attack tables. I love the idea. I don't yet understand properly of how in particular this could be implemented. But anyway, that might be another option for the further improvement of the speed of this sort of emoji generator. But again, like assuming the purposes of move validation that we're about to come just right in the moment, the speed of the emoji generator doesn't really matter that much. And if we're talking about using this chess engine as some sort of either front end or a back end library, in this case, all we need is just the internal board state and capability of making moves and taking them back, and that's kind of it. So we just need to make sure it works correctly, and speed doesn't really matter that much if we're talking from the library perspective. But obviously from the chess playing strength perspective, speed is probably the most important thing. But anyway, even having the fastest mode generator in the world doesn't yet obviously mean the strongest chess engine in the world, because the matter of the strength of the chess engine is how deep it can search, and the matter of how deep this chess engine can search is the matter of how optimized your search is. Well, in terms of alpha beta search, it's the matter of move ordering and how likely the cutoffs are about to occur. So the faster cutoffs occur, the more narrow search tree is, the faster the search is, and the stronger your chess engine is at the very end. If we're not talking about evaluation now, but just if we talk about the search. So that's kind of it regarding this sort of emoji generation part. And I've also improved GUI slightly a bit. So, well, I hope that I've turned the PERFT off. Yeah, I did turn the PERFT off. So now, well, apart from this nice little files and ranks been printed now, unfortunately, and I just need to change the layout or label a little bit. But well, no, I just want to get back my get my console back, because I would be showing you some API functions that have just started being available within Wukong chess engine. So first of all, we can no longer make moves invalid moves. So we can only make valid moves. Say I can move this white pieces twice. The screen is blinking because I have disabled cache here, so just don't get annoyed by that, please. Just showing you the idea. Well, probably I can show it like this, the way blinking, and then I'll get back to my console to show the API functionality. So now we can make the moves, and again, like, so I can make roam moves. I can make roam moves like this. Oh, this is sorry, this is the legal move actually, yeah. And we can actually make some moves. That's how it works. That's very simple stuff. So And now the interesting thing. So I've made a few moves here, and now we just have a look at the API part. So I'm creating a public API for this chess engine, so in order to make it serve in as some sort of a library one day. So not very too many functions are available within this API at the moment. Also another little update. I've separated the GUI. I've separated the on-click and on drag-and-drop handlers to the browser mode. I took them away from the engine object because it's more like the GUI stuff rather than the chess engine. And also I've added a little condition here. So only if document body is equal to null, which means that the HTML looks like this literally when it's kind of in the self-demonstration mode, let's say. In this case, this HTML is generated artificially and engine comes to this demo state that you can see here in the browser. But in case if, let's say, this script is being embedded within some sort of another document, I'm not providing like HTML and all the head and all the stuff. Let's consider that the real HTML would be having the body tag. And in this case, if we just update, we can see literally nothing here because this entire self-demonstration code doesn't fire actually. So just to give you an idea. And I will probably, most likely, I will provide the documentation how to create this GUI how to bind GUI events like on click and on drag and drop to if you want to reuse the functionality of WukongJS engine within some sort of your own project. So this might be handy. Well, so one day I really hope to make the documentation, probably some video tutorials on that as well. So let's get back to the self-demonstration mode. So literally just need to remove that body stuff. I'm sorry guys, just pressing Ctrl R and stopping my recording instead of updating the screen. I'm just used to press Ctrl R when I'm working in the browser. Sorry. So I really hope that I didn't drop much of the recording. Well, anyway, so let's assume that we've made a few moves here, right? And let's just get back to the API. So have a look at the API here and what we have. So, well, obviously we can draw the board and draw the pieces, or update the board, reference the internal chess board by, so get piece actually. This is used by this is used for highlighting purposes here within the drag and drop and on click event handlers. We can also would be able to set pieces in case when let's say there would be the mode. Let's say you want to create the mode when you want to set pieces from the GUI, not from the FEN string, but from the GUI, like pick up a knight, set it on the board, pick up king, set it on the board as well. So that's where the set piece function would be working. Move piece is again like it just handles the it handles the piece movements within the GUI made by the user. Well, debug is the only function that left from the previous time, is just literally made for debugging. So here from within this debug function, we can reference whatever internal function to actually debug it. And finally, this one, very interesting. So this one, takeback. So if we just combine this takeback with update board, this is what's going to be happening. Just want to show you this. Assuming that we have a move stack being implemented for the purposes of making moves and taking back, and assuming the incremental updates within the take back when we update in the board position and state variables, not from the copy. But well, even if that wasn't implemented, still it's going to be working. So I just can take this moves back, just get rid of the highlight square, just to give you an idea. So what's kind of happening here? I'm literally taking all the moves back. So you see, like, and if there are no more moves within the move stack, then basically we're not gonna be taken back anymore. So this is how it works basically. And what I'm really proud of is that, have a look at this. Let's have a look at this backup move stack. So our backup, this is it basically. Yeah. So this is the move stack that is used within the move generator itself. So every time we're making a move recursively and taking back, this stack is used. But also, it's gonna be used within the GUI. It might be used within the GUI in a quite pretty handy way. So this is where the UCI protocol comes onto the stage, and this is the protocol that is usually used to connect your chess engine with the existing GUIs like Arena or QChessCli or whatever. But the point is that the helper functions needed to serve the purposes of this UCI protocol also might be handled within the GUI in the web browser, believe it or not. But that's the topic for a separate video that I'm about to record as soon as I would implement those helper functions, basically. So I hope to demonstrate you. So the idea is, like, before this, I was using a separate stack to keep track of the, like, say, PGN, but now I've realized that I can use the I can use this internal stack to serve both purposes, the mode generation and also keeping track the state of the game as well. Because again, like in UCI case, we just upload the moves, we make a bulk moves and upload, so like E7, E2, E4, E7, E5, so on, and then we just ask the engine to search the current position. But no one prevents us from basically sliding back and forth within our move stack. We have a pointer or index, in case of JavaScript, better to call it an index, pointing to the specific position within this backup move stack. So that's kind of it. And there is some sort of architectural part that I'm really proud of, because it's really cool when you're reusing the internal mechanisms of your chess engine to serve multiple purposes at once. Well, for me personally, it's kind of very pleasing stuff to consider. Well, okay, guys, so this is it from my side. The development is going on, and to be honest, I'm getting motivated more and more every time, because refactoring code actually a very good thing to motivate yourself to keep the work. So even if it won't be really, this engine won't be really that great in terms of playing strength, at very least I can turn it into a very powerful library, because it has lots of functions, good tested functions within inside to be reused by programmers for whatever reasons that regards to chess programming. So I don't know how many functions in particular I'm gonna be exposing to this public API. For now, I'm not trying to expose those functions that are not currently used outside of the engine, and the only functions that are now used outside of the engine is this only this GUI bindings. That's kind of it. And again, like when there would be the UCI protocol, maybe I will need a couple more functions to expose. It's hard to say. I just need to implement that first, and then I will know. And also, I think it would be a good idea to expose the engine constants, so we could reference the piece codes, converting piece codes to Unicode pieces, converting square coordinates to user readable coordinates, and so on. So making use of the site, working with the board, again, like setting all this in peasant, castling, 50 rule move, and so on and so on. So if we want to set the position from the GUI, this might be very useful, very handy. And also I need to think about how in particular I'm going to be implementing the features, like when it comes to not this self-demonstration mode, but like a front-end library mode, and also how would it be working as if this would be a back-end library mode. And also I'll need to distinguish between the front-end and back-end API functions availability. So literally I won't be able to either draw the board or update the board via Node.js, because it doesn't simply doesn't have the document object, no browser. It's the console applications, and it's not an option there. So, well, the most easy thing is just say a type of document is undefined, then do nothing basically, or just return a string like this function is only available in the GUI. Probably the thing that I would most likely about to be doing, well, at least for now. So this are the old news regarding the development progress, guys. So please let me know in the commentaries what do you think about this project. So it kind of starts to look like something interesting at the moment, I believe. And again, I'm not gonna be for now. I will drop a search part for now. I just want to work with this bindings, like this UCI protocol to make sure that I manage all the stuff properly, and then I will come down and go for implementing the search part, which is gonna be really exciting as well. So this is it from my side for now, guys. For now, I think this is it. So yeah, let me know in the commentaries what do you think. And again, I have a little question. So for some reason, every single video that involves some perf testing inside, for some reason it gets disliked. I have already 2 videos and they both are disliked. So just let me know if there is anything wrong with the perf test videos. So maybe I don't know, like, what's wrong with those. Maybe it's not the same guy who's clicking those dislikes, but I just really want to have some feedback. So is it a matter of a topic, or maybe you just don't like me or my content, so it's fine as well, but just want to be aware of what's going on there. Okay guys, so this is it from my side. Until the next time, and take care.